SpaceX just did something no one saw coming with its Dragon spacecraft, and this bold two-pronged move is shaking the entire aerospace industry. It all started with what seemed like a routine splashdown. A textbook landing so precise, it was almost boring. But beneath that calm surface was a daring strategic play that stunned engineers, competitors, and even seasoned industry veterans. Can you guess what they did? No outsourcing. No off-the-shelf purchases. They built it every part from scratch. How did SpaceX turn a potential setback into a massive opportunity for just $2 million? And why does that matter for the future of humanity? This is Space Now, and the story begins right here. After its main parachute supplier, Pioneer Aerospace, filed for bankruptcy, SpaceX didn't flinch. They didn't wait around for a new contract, nor did they rush to buy replacement parts from third parties. Instead, they rolled up their sleeves and tackled the problem the only way Elon Musk ever does, by taking full control from start to finish. Why is this such a big deal? Because it could redefine safety standards for atmospheric re-entry, not just for cargo, but for people. Safety cost control, faster manufacturing timelines, and most importantly, reclaiming ownership over a critical system that has plagued the space industry for decades. Ever heard of the term vertical integration? Keep that in mind, it's the strategic game-changer SpaceX is doubling down on. So what exactly did SpaceX do differently with Dragon's parachute system? Why is the entire industry buzzing about it? And could this move reshape the future of human spaceflight? Don't take your eyes off today's video, because what you're about to discover might flip everything you thought you knew about rocket science. This is Space Now, breaking down every bold move in the new space age. On the morning of Sunday, May 25th, the Dragon spacecraft wrapped up its 32nd commercial resupply mission to the International Space Station with a smooth ocean landing off the coast of California. At around 18,000 feet, 2 drogue parachutes deployed to stabilize the capsule. Then, at roughly 6,000 feet, 4 main parachutes opened wide, slowing the descent and allowing Dragon to touch down gently, almost like falling into the arms of the ocean. Sounds like a familiar mission, right? But don't let that familiarity fool you this time. There was one critical difference that changed everything. And that was the drogue chutes. No outsourcing, no off-the-shelf parts. For the first time in history, SpaceX designed and built the entire drogue parachute system completely in-house. According to SpaceX, this new series of drogue chutes was completely redesigned based on real-world testing and data-reinforced joints, stronger high-tensile synthetic cords, and optimized chute canopies engineered to deploy faster, cleaner, and with reduced error margins during that high-stakes deployment phase, arguably the most critical moment for the entire capsule. Did you know in spaceflight even a slightly twisted or misaligned parachute can flip a capsule accelerated uncontrollably or lead to a catastrophic landing? Every millimeter of the parachute structure is the result of thousands of hours of simulations testing and data analysis. Let's take a step back to understand the bigger picture. For years, SpaceX relied on the manufacturer Pioneer Aerospace to supply its drogue parachute systems. Pioneer was a veteran in the field, having contributed to several major space programs, and possessed the hard-earned expertise to produce flight-rated parachutes, one of the most technically demanding components in aerospace engineering. Then, an unexpected event shook things up. Pioneer's parent company filed for bankruptcy at the end of 2023. That left SpaceX with 2 options: find a new supplier or take over the entire production system. And yes, you guessed it, they chose the second option. SpaceX acquired Pioneer for $2.2 million, a strategic move that turned risk into opportunity. Now, SpaceX holds full control over the quality design and production of its drogue parachutes. No more worrying about late deliveries from suppliers. No more waiting for external technical approvals. If something needs fixing, they fix it. If it needs upgrading, they upgrade it. Most importantly, they can test, measure, and fine-tune everything in real time, something very few space companies dare to do. Remember when ULA famously sounded the alarm over not receiving engines from Blue Origin? The now iconic quote, "Where are my engines?" Jeff stands as a clear reminder of the risks of relying too heavily on outside partners. This was a costly lesson in vertical integration, the strategy of consolidating a company's supply chain by producing key components in-house. And SpaceX is no stranger to that game. They already manufacture the Merlin engines, Falcon rocket bodies, flight computers, avionics systems, and even their own spacesuits. They also own and operate their entire launch facility, Starbase, in Boca Chica, Texas. All of this forms a closed-loop ecosystem where every tiny detail is under SpaceX's direct control. Can you think of another example of vertical integration in the space industry? Drop it in the comments, we'd love to hear your take. So in the end, why did SpaceX choose this path and stick with it so relentlessly? The answer might sound simple: cost savings. Think of it like cooking at home instead of dining out. You're not paying for the chef or the service, and you control every ingredient. For SpaceX, cooking in-house means saving millions of dollars while cutting out expensive middlemen. But here's the twist. Vertical integration wasn't even Elon Musk's original plan. At first, he tried to buy rockets from Russia, but failed. American suppliers were far too expensive. So Elon Musk did what no one expected. He decided to build the first rocket, Falcon 1, almost entirely in-house at SpaceX. What's your take on SpaceX's strategy of complete autonomy? Do you support or oppose vertical integration in the aerospace industry? If you think it's just about a small detail, then you haven't quite grasped how Elon Musk is rewriting the rules of the game. Space Now is here to break it down for you. To truly understand SpaceX's technological self-reliance strategy and why they're willing to take on the entire aerospace industry, you have to go back in time to the post-Cold War era. After the Soviet Union collapsed in 1991, then U.S. Secretary of Defense Les Aspin announced deep cuts to the defense budget. That decision rocked the defense industry, especially aerospace, like a hurricane. The result? A wave of consolidation that forced many companies to either merge or disappear entirely. Which names survived that storm? Lockheed Martin, Northrop Grumman, and Aerojet Rocketdyne were among the few giants that remained standing thanks to decades of massive mergers and acquisitions. But what few people talk about is how this M&A wave didn't just affect the top-tier players, it rippled down through the entire supply chain, Tier 1, Tier 2, even Tier 3 suppliers. The fallout. Many specialized manufacturing skills and complex chemical fabrication techniques that once gave the U.S. a leading edge in space tech have slowly faded into obscurity, lost like smoke in the wind. Rob Meyerson, former president of Blue Origin, put it bluntly: when you try to source components in the U.S., you basically have no options left. Today, many suppliers offer products they've never actually made themselves. They simply inherited them through M&A deals. And to start manufacturing those parts again, you'll need to pay an enormous engineering fee just to relearn what should have been foundational knowledge. That's exactly why, if you have the capital, the ambition, and the right strategy, going fully self-reliant, or more precisely vertically integrating your entire tech value chain, is not just viable, It's a smart move. But the story doesn't end there. There's another driving force behind America's strategic pivot: global geopolitics. For a long time, the U.S. depended heavily on Russian rocket technology, especially the RD-180 engines made by NPO Energomash, which powered the Atlas V rockets used in national security missions. It didn't stop there. NASA also had to hitch a ride on Russia's Soyuz spacecraft to get astronauts to the International Space Station ISS. But in 2014, a geopolitical earthquake hit when Russia annexed Crimea. Alarm bells rang across Washington. Congress quickly responded with the 2015 National Defense Authorization Act, NDAA, which mandated a complete phase-out of the RD-180 engines by 2022. And from there, a new race began: the race to completely end dependence on Russian technology and establish domestic aerospace independence. However, vertical integration isn't a path paved with roses. The upfront costs are a massive mountain to climb. Take the example of the small satellite manufacturer TAN Orbital. They invested heavily in building a modern factory and purchasing state-of-the-art production equipment, and now manufacture about 85% of their components in-house. Sounds impressive, right? But the reality: every quarter, they still lose tens of millions of dollars, and no one is certain if those investments will ever pay off. On top of that, hiring is a genuine battle. Finding engineers capable of designing and producing high-tech components internally is incredibly rare. Add to that another beast: regulations and legal hurdles. Navigating the maze of compliance with hundreds of technical standards for each part is a grueling journey that demands time, resources, and exceptional cross-disciplinary coordination. But some have made it work. And none other than SpaceX not only builds everything in-house for themselves, but also sells their technology back to others. Can you imagine a private space company that builds satellites, launches rockets, and also acts as a supplier of laser communication systems to outside customers? So how do they pull this off? The secret lies in repurposing the localization technology developed for their Starlink satellite system. SpaceX has equipped thousands of their satellites with laser communication devices, creating a high-speed data network capable of up to 100 Gbps per link, with ultra-high reliability and near-zero latency. They call this system plug-and-play laser, designed as a modular solution that external customers can easily integrate into their own satellites without starting from scratch. This not only saves costs, but also significantly shortens the time to market. Because the entire system is manufactured in-house, SpaceX maintains strict control over quality, can easily fine-tune and upgrade the product, and most importantly, can keep prices competitive while ensuring top performance. Some early customers have already appeared, including VAST, the company developing the Haven 1 contracts One commercial space station, which will use Starlink's laser technology to operate its communication system. Through missions like Polaris Dawn, where SpaceX installed and demonstrated the laser communication technology on the Dragon spacecraft, they've not only proven feasibility, but also built trust with the market and potential partners. What do you think about this bold move? Should future space companies follow SpaceX's do everything yourself model, or focus on specializing in a specific field? Please share your thoughts in the comments, because the future of the space industry might depend on the mindset you have right now. SpaceX is targeting an extremely promising market: laser communications in space, expected to boom strongly by 2034. It's a smart move to turn in-house technology into a new revenue stream, not just a technical achievement. And to strengthen the presence of the Starlink system in orbit, SpaceX isn't going the slow drip route, they're going all in with Starship. What if you could launch hundreds of satellites into space with just one flight? That's exactly what Starship, the futuristic giant, is designed to do. With its massive payload capacity, Starship can deploy multiple Starlink satellites at once, including upgraded versions drastically lowering the cost per satellite, a game-changer in the global satellite constellation expansion strategy. Imagine a machine standing 400 feet tall, 30 feet in diameter, consisting of two stages, the Super Heavy booster and the Starship spacecraft. Both are powered by advanced Raptor engines, burning a mix of liquid methane and liquid oxygen, a highly efficient combo optimized for performance and reusability. Its stainless steel body lets it survive the harsh re-entry through Earth's atmosphere, a true space warrior. Can you guess? Starship can carry 100 to 150 tons of cargo to low Earth orbit. But it doesn't stop there. Its mission also includes landing humans on the Moon as part of NASA's Artemis program, and even further taking humanity to Mars. All this is within reach, thanks to its fully reusable design, in-orbit refueling capabilities, and even catching the booster on the launch tower, something never done before in space history. And if you think Starship today is already cutting edge, wait until you hear about the Block 2 version. Elon Musk confirmed that Super Heavy version 2 will be taller, stronger, and smarter. The second stage alone will be 4.3 feet longer, reaching a total length of 237 feet, allowing for more fuel and extended range. One key upgrade is moving the grid fins lower to improve stability under extreme temperatures caused by hot staging that is igniting the next stage before the current one fully separates. The new hot staging system will feature longer thermal protection rings and larger exhaust vents, simplifying structure while improving stage separation efficiency, and notably, it will be reusable. But wait, don't forget the upper stage. The second version of Starship will carry more fuel, have a lower dry weight, increased reliability, and according to Elon Musk, could still keep 6 Raptor engines. The spacecraft will grow 6 feet longer, reaching a total of 171 feet. Combined with the Block 2 booster, the entire system will stand 408 feet tall, making Starship the largest space vehicle ever built. At over the height of a 40-story building, is Starship redefining what a rocket can be? Could it reshape the space race the way Falcon 9, once did? That's today's journey with Space Now, where we don't just look up at the sky, but also understand what awaits beyond orbit. If you're excited about the future SpaceX is building, or simply fascinated by humanity's steps beyond Earth, don't forget to follow, like, and share this video to spread the spirit of space exploration to more people. See you in the next video, where space is no longer distant, but part of humanity's ongoing journey.